Good day. Welcome to this session on multi-stakeholder data bridges, making data work for cross-domain grand challenges. I'm Simon Hodson, Executive Director of CODATA, and I'll be chairing this session, which involves talks about a number of projects and initiatives that share the objective of creating multi-stakeholder data bridges. What do we mean by that? Will become apparent during the session, but a common feature is an effort to make data and other resources richer, more valuable, and easier to combine. The presentations speak about projects and initiatives doing the essential work to add value to data and to information. That process of adding value involves detailed technical work on semantics, on definitions, and it also requires collaboration across communities, across sectors and scientific domains. It can sometimes sound detailed, difficult, and technical, but it's fundamental, and the benefits of that work are enormous. And we hope to give you an indication of why that is the case during the course of the presentations. This session has been convened by CODATA, which is the Committee on Data of the International Science Council. As part of the International Science Council, or ISC's new action plan, CODATA has been tasked to develop an international collaborative program, a decadal program, because of the size of the challenge, entitled Making Data Work for Cross-Domain Grand Challenges. And that will be launched at the ISC's General Assembly in 2021. We're beginning to put in place the components of that work, and some of the presentations today will speak to those activities. The premise of the Decadal Programme is that the major scientific and global challenges of our age, things like tackling climate change, mitigation of climate change, understanding and responding to hazards, the growth of cities, infectious diseases, and the current pandemic are necessarily cross-domain and cross-sectoral. Addressing these issues requires many things, including the contribution of science, collaboration across domains, evidence-based policy and action, and evidence that is soundly based on data. Addressing these issues requires fundamentally for us to improve our ability to combine data and to combine data from different sources. This requires openness, it requires standardization, particularly in relation to terminologies and metadata, and it requires collaboration. The presentations which follow exemplify these attributes and our message from this session, which is openness, standardization, and collaboration. In the first part of the session, we have 3 examples of extremely valuable work on terminologies and semantics applied to issues of the first order of importance. This includes presentations on the review of hazard definitions and classifications that will underpin Sendai reporting globally. Presentations on the activities to enhance the records of the UN General Assembly and to make the resolutions machine readable, and on the application of internationalized resource identifiers for sustainable development goals to make the data and information relating to the SDGs more accessible and usable. Building on these examples, the next 3 presentations will chart an arc from challenges with data and information on the ground to some possible solutions. We'll hear from a cross-domain case study in infectious diseases, through which the scientific community is contributing to enrich knowledge in relation to specific SDGs. Then 2 presentations will explore the prospects for cross-domain and multi-sectoral data bridges using standards-based semantics and metadata, and we'll close with a summary of the session. So thank you very much for continuing to watch this session and for your engagement with these activities. And I'm going to hand over now to our first speaker, which is Virginia Murray from Public Health England and the CODATA Executive Board. Over to you, Virginia.
Thank you so much, Simon. It's a real privilege to be part of this group. To me, the most vital thing is to be able to share what we're doing on our work that we're doing on hazards. It helps to show the collaboration, the partnerships, and all the things that you have so well described. And I hope this will be a useful summary. Understanding hazards has been quite an issue, and we've had to deal with these grand challenges in a very interesting way. And I'm very pleased to say that the report on hazard definition and classification review is now published with the support of the International Science Council and the United Nations Office for Disaster Risk Reduction. What I'm going to try and show from this report is this report, but also what it means to possible future discussions with statisticians and many other colleagues. The Sendai Framework was one of the great outcomes of 2015 and the UN landmark agreements of the climate change and the SDGs with the Sendai Framework. And one of the things that the Sendai Framework brought with such clarity was the need to have very clear global outcomes, guiding principles, priorities for action at all levels, and these 7 global targets of reducing mortality, affected people, economic loss, and indeed damage to critical infrastructure and disruption of basic services, particularly health and educational services. And increase each country's national and local disaster risk reduction strategies, which is the global target for 2020, and building on international cooperation to all countries, particularly developing countries. And something that I think is very special is the availability and access to multi-hazard early warning systems and disaster risk information assessments to all people by 2030, so that they can understand what to do when the warnings come. One of the most important things, though, is to measure the implementation of the Sendai Framework, and the Sendai Framework Monitor System is now live. It has 38 indicators supporting these 7 global targets, and these indicators are absolutely critical for us to understand the impact of this framework. And one of the things that the Sendai Framework has in it, in paragraph 24J, is the need to strengthen technical and scientific capacity to assess disaster risks, vulnerabilities, and exposure to all hazards. But we've been struggling with the term all hazards. So with the support of UNDRR and the International Science Council, we have set up this preliminary project to understand the issues around what the Sendai Framework really means in hazard terminology and classifications for partners addressing this all hazards paradigm. To do this, there have been the most wonderful collection of colleagues and partners showing that collaboration is simply critical. And you'll see under the International Science Council partners that CODATA has been at the heart of the delivery of much of this. But under UNDRR, there have been an incredible collection of UN agencies and partners from the World Meteorological Organization, the World Health Organization, and many, many others who've contributed to so much of our knowledge and understanding. But none of this would have worked without the support of the International Humanitarian Organization partner, the International Federation of the Red Cross Red Crescent, and the bringing in of industrial science partners, at this time the Insurance Development Forum. Now, these are the heart of our technical working group, these wonderful friends. But we've also found that there were many who were interested in this project who volunteered to join and help us. And one of the things we've done is to reach out to many more. So it's been a real learning opportunity to see how we can engage. The whole of the hazard review and classification project is summarized in this rather complex diagram. So I'm going to take you through it and try and make it less difficult to read. The first thing was to understand the scope of the hazards that are listed under the Sendai Framework, and to do this, we took the UN General Assembly definition of hazards as a process, phenomenon, or human activity that may cause harm. And this is described in the UN General Assembly that was finally adopted in February 2017 and now published on the UNDRR website. A hazard is this process of phenomena or human activity that can cause loss of life, injury, or other health impacts, property damage, social and economic disruption, or environmental degradation. But underneath it, there's a whole series of annotations, as I will show you. And these annotations are really very complex for statisticians and others to understand exactly what we mean by biological, environmental, geological and geophysical, hydrometeorological and technological hazards. So we went away and discussed this with many and reviewed all the sources we could find, both in the United Nations networks, but also in the scientific networks, and we consulted with many expert communities. We ended up with very clear inclusion criteria, and we had a hazard list, which includes hydrometeorological hazards, extraterrestrial hazards, geohazards, environmental hazards, such as these wildfires that have been happening all over the world, in California, in the Amazon, in Siberia. But of course, at the moment, we have COVID as a representation of a global pandemic, showing how important biological hazards are. We then went on to look at chemical hazards and others, but we've also been much involved with looking at technological hazards and indeed societal hazards, including even civil unrest. So we now have 302 hazards that are currently included on the hazard list, and we think that is a very important way to consider it. And from these, each hazard has a primary definition, preferably at the highest UN or other authority, with clear references for scientific definitions, metrics where they are global and can be easily understood, with annotations where relevant, and the ownership of the definitions with the name of the contributor to developing these hazard information profiles. From this, we brought out 6 recommendations, which I will share with you. There is without doubt a need for regular review and update, the need to facilitate the development of a multi-hazard information system, which CODATA has been much involved with. But the other thing is to engage with the users and the sectors for greater alignment and consistency of hazard definitions to see if this preliminary work is actually going to deliver what might be needed. And we also know that this hazard list has to actively engage policymakers and scientists in evidence-based national risk assessments processes and all the things that are needed to manage risks of emergencies and disasters. We know there's further work that needs to be conducted, but we also need to address cascading and complex hazards and risks. So let's look at the recommendation on engaging users. There are so many users, but to us, one of the most important groups is the United Nations Statistical Division and the National Statistical Offices to ensure interoperability and standardization of statistically relevant definitions so that we can work across these 3 UN landmark agreements. This should ensure synchronization amongst global and national statistical mechanisms and processes. But of course, these definitions are not just for those people. It is for so many more to produce a holistic, consistent approach to hazard identification and definition if we can achieve it. And I wanted just to show you very briefly who the technical working group members have been. And I thank Simon Hodson in particular for CODATA, but one of my very good colleagues, Simon Cox, who's also on the executive committee of CODATA. But you'll see the many others from all over the world who've really engaged to deliver this product. And there are co-facilitators from ISC and UNDRR, and I thank Anne-Sophie and Irina very much. But there's a large support team, library services, review mechanisms, all sorts of things in our 400 group that have been supporting us. And these are the authors of the hazard information profiles who have come in from all over the world to contribute. But we've also had an incredible number of reviewers, and I thank them all so much for what we've been trying to do. So in conclusion, this report is a first step to take the Sendai framework forward with the SDGs and the Paris Agreement on climate change, to provide a common set of hazard definitions for monitoring and reviewing implementation, which calls for a data revolution, rigorous accountability mechanisms, and renewed global partnerships, so much needed at the time of this global pandemic. Thank you.
Thank you very much, Virginia, for that overview of the new report and the review of the Sendai hazard terminology. Our next speaker is Remo Lally from the United Nations. Remo.
Good day, colleagues. Good day. This is Remo Lalli, and I'm the Secretary of the High-Level Committee on Management of the Chief Executive's Board for Coordination. My presentation today has to do with digital document management in the United Nations system, and an initiative that we have launched in the High-Level Committee on Management, which is briefly called HLCM, to unleash a new paradigm in digital document management. The work that we have conducted, that we've launched in HLCM, it's based on the fact that in the United Nations, we produce a really large volume of documents. And these documents are not only produced within the system, but we also manage an amount of non-UN documents that has to be processed. And this is posing significant challenges to the UN system. Effective and efficient information management and accessibility of this documentation is well beyond the human processing capabilities of UN organizations. To address these challenges, UN organizations in HLCM must overcome the paper paradigm, where documents are designed for humans to read, to quote Sir Tim Berners-Lee, but not for computer programs to manipulate meaningfully. This initiative is definitely aimed at moving to a new form of content which is meaningful to computers, to unleash a revolution of new possibilities. Now, in HLCM, in late 2017, we went around organizations of the UN system, which is more than 20, in fact, more than 30 of them at the time, to check whether investments had been made in developing a common document management system, which could be used for document management across the system. And we thought, and we looked at it, and we saw that there was no investment made at the time. So we invested in an analysis of what could be a possible framework for UN semantic interoperability for normative and parliamentary documents. And in 2017, we adopted the so-called A Common Torso for the United Nations, which is a customized version of the A Common Torso OASIS standard, and it also includes a specific ontology meant to encompass the entire United Nations system, called United Nations Document Ontology. So AKN for UN, that's the acronym, is the localized version of A Common Torso. And it represents parliamentary, legislative, and judiciary documents in a machine-readable format, not only ideal for multi-channel dissemination and long-time digital preservation, but also to support machine processing to enable the development of smart information services. We have many partners in this undertaking. We have, to begin with, the key actor in this undertaking in the United Nations is the United Nations Department of General Assembly and Conference Management. And you will hear after my presentation an implementation pilot by the DGACM, and Cecilia Elizalde will speak about it. But a common torso, an XML, is a standard which is now used in by several other entities across the world, beginning with the Senado of Brazil, the US House of Representatives, the European Parliament and the European Commission, the UK Archives, the Senate of the Italian Republic, and many others. So we're building on ground which has been already explored and endorsed by many other authoritative actors in the United Nations and elsewhere. Once the semantic interoperability framework was adopted, then we had to move as a system to implementing it. So to make it sure, from a conceptual and intellectual initiative, we would move to the actual implementation and action on it. And in order to do that, we launched a number of pilot projects with several partners within and outside the organizations. A key partnership that we launched was one with Microsoft Azure. These pilots were meant at providing a clear evidence of the benefit that machine readable documents have, and to therefore convince organizations to move forward and to invest even more in implementing this standard across their divisions. The specific partnership with Microsoft was for the development of an automatic tool to extract and analyze information from UN system documents, in particular, classifying structures, for example, titles and identifiers and different types of paragraphs and entities such as persons, roles, countries, places, etc. This is the first and most important step, as most of you know, of the automatic markup process. Once identified, then each entity can be relatively easily marked up. This was quite a successful undertaking with Microsoft, and we are now looking at developing a second phase of our collaboration with this important partner. Another key, I would say one of the most important and one of the dearest to me initiatives that we have launched and completed is the development and adoption of uniform resource identifiers for SDGs. The common identifiers for sustainable development goals, targets, and indicators, which the HLCM developed in coordination with the UN Statistics Division, with the Department of Economic and Social Affairs, and of course with the Department of General Assembly and Conference Management, it's indeed a common system, a system of common internationalized resource identifiers for goals, targets, indicators, and related series, statistical series. These URIs are now available on a portal provided by the UN Library, which also hosts the UN Bibliographic Information System, UN-BIS taxonomy. Why is this initiative so dear to me? Because these common identifiers will contribute to the transformation of the current SDG-related document and data assets into a homogeneous system of information, into a homogeneous information space, and provide the foundation to enhance the automatic retrieval, processing, and integration of information related to SDGs. These IRIs have also been mapped to the UN Environment SDG interface ontology and to the UN Bibliographic Information System vocabulary to enable the use of these resources seamlessly in linking documents and data from different sources to goals, targets, and indicators, and closely related concepts. The United Nations Statistics Division, in collaboration with the Division of Sustainable Development Goals of DESA, has also developed an initial pilot application that demonstrates how the common identifiers can be used to transform statistical data sets from the global SDG indicator database into a linked open data format. The road ahead in our undertaking is still long. We're looking at more hard evidence of the benefits. Therefore, we need more pilots, and opportunities like the one we're having today is to share the voice, spread the voice, and bring more organization to the table of AKM for the UN and encourage them to develop more pilots. We need more collaboration, but we also need to create new tools like the one we have put together and launched with Microsoft. Single standards like a common TOSO and the URIs are the way ahead. This is the way we are investing in the United Nations to adopt international valid standard, professional standards that can take us forward within a world which is always more interlinked. With this, dear colleagues, I come to the end of my presentation and I pass the floor to the next speaker. Thank you very much.
Thank you very much, Remo, for that insight into what the UN is doing to link documentation and to provide identifiers such that the information can be more machine readable. We'll have a further example of that from the next speaker, who's Cecilia Elizalde, also from the United Nations. Cecilia, over to you. Cecilia, you need to unmute.
Okay, sorry about that. Good morning, good afternoon. My name is Cecilia Elizalde. I am the Director of the Documentation Division in the Department for General Assembly and Conference Management of the United Nations in New York. And my presentation is a follow-up of the presentation of Remo, because we have implemented actually some of the ideas that we discussed in the context of the project with the HLCM. So in my division, we are, the documentation division is the translation services of the United Nations in New York. And we are tasked to process in the 6 official languages of the United Nations, Arabic, Chinese, English, French, Russian, and Spanish, all the parliamentary documentation of the UN main bodies, including the General Assembly. And we publish these documents in Word and in PDF format. Just to give you an idea, we process in New York 134 million words of parliamentary documentation, which is about 400,000 pages and 11,000 documents. And that's only in New York. We process an additional 60% more in our other duty stations, which is Geneva, Vienna, and Nairobi. And on top of that, I mean, there is a lot of other documentation at the United Nations. So it is a very large operation. Another fact that I would like to share with you is that only in my division, we are about 550 language staff processing all these documents. Plus an additional 15 or 20% of capacity, additional staff members, linguists translating documents. So this is just to give you an idea that, you know, we produce a lot of documents, a lot of information, and this information, even if we make it available to the public through the official document system of the United Nations, there is a lot of research and digging that needs to be done in order to actually be able to find what you are looking for and also to link that. So that was one of the main drivers for us that we want to find a better way to provide information. This is why we have collaborated in the project that Remo presented, because we see 2 main benefits. First, to provide new information services to member states, to the general public, but also to find more cost efficiencies in the process of translating and producing this documentation, because as you can see, with all these numbers of these linguists, these are very costly operations. So these were our 2 main goals: to provide new information services, to leverage all the information that we have stored in these documents, and to automate some of the processes to make our operations more cost efficient. So this is why we are following the Secretary General Data Strategy that calls to identify user cases to implement a culture of data stewardship instead of a culture of data ownership. I should say also that in our department, we are very active in innovation, and we have developed internally a set of language tools to translate documents, computer-assisted translation, terminology, etc. So we had also an internal team of developers and computational linguists that were entrusted to actually implement a machine-readable approach to our documents. We also, these tools that we produce, and I am the executive of this project that is called GText, it's a project to develop language tools, is shared also with other organizations of the UN system. So in this context, in the context of the GText project, we developed a converter, what we call eLUNa. eLUNa is the name of our main translation tool, which is electronic languages of the United Nations. And in this context, we developed this prototype to convert only, and very specifically at the beginning, the resolutions of the General Assembly of the United Nations into a Comantoso standard for the United Nations. And then to compile all these resolutions in a volume that we are mandated to produce every year. So what does this converter? So we produce the documents in Microsoft Word. We translate them in Microsoft Word. We issue them in Microsoft Word in the 6 official languages and PDF. But then we have like this automation that will go into the resolution and will try to find structural markup, semantic elements, and will produce a document that is machine readable. But on top of that, this converter will find information that is not present in this Microsoft Word document in the resolution itself. For instance, which member states have adopted this resolution, which member states were against this resolution. This information normally is not stored, I mean, in the resolution, so we bring this information and we embed it in our machine readable resolution by using this converter. The converter also gives the user, I mean, a form where we can check if this identification has been done correctly. But we also add into in this XML resolution, we also add the Sustainable Development Goals, and we identify them automatically using the application that Remo mentioned, which is called Link SDGs, that was developed by the Department of Economic and Social Affairs of the United Nations. And we also add from the UN Business Hours and Euroboc the subjects. So in an automated way, we bring this resolution that was just a document and we enrich it with a lot of metadata that is not only present. So we recognize the elements, the semantic elements, the structural elements, and we add on top additional metadata. And using this metadata, and using the content of the resolution and the structural and semantic tagging, we can build together these volumes of resolutions that are compilations of what the member states have approved and the text itself. In the past, just to give you an idea, putting together these volumes of resolution and gathering all this information used to take 6 people 6 months, because it's a big number of, a lot of work. Today, we can do it instantly, so we can see the efficiencies. What I was saying also, that besides this goal of improving the efficiencies of the United Nations, we have this other goal to bring new services to member states. What we have done is that we have provided all this corpus of machine-readable resolutions. We have created a website, and we put all these resolutions there so that this can be downloaded and somebody else can create other applications using our Acomantoso for the UN resolutions. These are resolutions in all the 6 official languages, but on top of that, we have started exploring how to present the information contained in a document in visual way. And you can see here, I mean, all these resolutions, the public, the general public, member states, researchers can actually see how these resolutions visually, how these resolutions, for instance, have evolved over time, which countries have been for or against a particular topic. And in this web page, we have filters, so we can create a different visualization. So the plans for next year is that we have been successful in creating these machine-readable resolutions, increasing efficiency, and also in providing new services. So we want to expand it to other categories, and we want to start another project with budget documents. We also want to identify other opportunities to create automatic content using the metadata. We have a lot of documents that are just compilations of titles or compilations of dates, of meetings, etc. So this can be created automatically. And we want to explore the possibility to share this eLUNa converter to make machine-readable documents with other organizations of the United Nations, following the same approach we have to share our tools with other organizations. This is what we are doing in the GTEx project with our translation and terminology tools. So if you want more information, we have a video there in these links, and I hope these presentations are going to be available. There is the link to our webpage. There is the link to this corpus of machine readable resolutions of the United Nations. And in any other question that you want to ask us, we are very available and willing. Thank you very much.
Thank you very much, Cecilia. So that sort of marks the halfway point of this session. We've heard these applications or these examples of applications of international standards in work within or related to the UN system to enable and enhance important processes. And now, as indicated in my introduction, we have 3 presentations which complement those examples by charting an arc from challenges with data on the ground to some further possible solutions that allow us to build cross-domain data bridges. So our first presentation in this second part of the session is from Chifundo Kanjala from the London School of Hygiene and Tropical Medicine. Over to you, Chifundo.
Thank you very much, Simon. Good day. I'm Chifundo Kanjala. I work at the London School of Hygiene and Tropical Medicine as a data documentalist, and I'm based in Malawi. I'm going to talk to you today about work that we're doing in the African region to create cross-site data for infectious diseases, and how we are enhancing the value of these data sets so they can be used beyond the primary producing team for those data. I'm going to talk about data coming from health and demographic surveillance systems and how over time we're building the capabilities to enrich those data. Here I'm showing one of the challenges that we have in Africa and also to some extent in Asia and other parts of the world, the scarcity of burden of disease data. In the map there, we see that in the African region, there isn't much data to do with cause of death. So this is just an indication of the general lack of data, health data from the population. So with this lack of burden of disease data, vital registration is often incomplete in many African countries. Some of the data that are available come from decadal population censuses, which are 10 years apart, so and also not as detailed. We also have repeated cross-sectional national surveys, which kind of try and fill in this data challenge, but they do not have longitudinal links to tell stories over time about the health of the populations. On top of that, we have fragmented healthcare information systems. So at the end of the day, there is a general lack of data. To try and address that, over the years, health and demographic surveillance systems have been established across Africa and Asia. I will concentrate on the African health and demographic surveillance systems. So they partly address the lack of vital registration and lack of population health data. The work that I'll talk a little bit more about is what we are building on top of the health and demographic surveillance systems to make those data richer, more valuable, and shareable. A little bit more detail about health and demographic surveillance systems. These are community-based longitudinal monitoring of vital events, births, deaths, and migration, and health outcomes. So they complement data, official sources of data, by providing localized sources of detailed population-based health data. On top of the vital registration, vital events, they also serve as platforms for clinical trials and general population-based health research. The data coming from these health and demographic surveillance systems tend to be very complex, owing to the very complex field and office data management procedures, because they are generally open cohorts. So people come into the populations that are being studied, and they leave the populations as they go about their lives. So it's up to the team producing or managing those data to properly keep track of all the dynamics in the population. This slide shows us a very high level setup in a health and demographic surveillance system. Usually a health demographic surveillance system starts with a baseline census within a properly geographically demarcated area. And then over time, following up the initially enumerated population, recording births and in-migration to increase the population being studied, and deaths and out-migration to reduce the population that's being studied. So on top of this basic demographic frame, various disease studies are nested within that. So the health and demographic surveillance systems provide very detailed scientific data, but in a very localized area, which is not nationally representative. But the depth and the longitudinal aspects of the data enable relationships to be studied that cannot be studied from data such as census or national cross-sectional surveys. But because of their sizes, one health and demographic surveillance system cannot address some questions to do with a region. For example, if you want to see how HIV patterns are rolling out within the Eastern African region, you can't use one health and demographic surveillance system. Also, when you're looking at things like cause of death and issues such as those, it's the statistical, that you run into statistical power issues because of the numbers involved. So as a way to address that, over the years, there have been some collaborations among the health and demographic surveillance systems. Among them, the in-depth network, which has demonstrated the benefit of working together and the standardized demographic data. The Alpha Network, which is focused on HIV research in Eastern and Southern Africa. SAPRIN is a group within South Africa, so getting funding from the South African government. So the South African government has formalized the support of health and demographic surveillance systems. And then the Inspire network is kind of building on top of these previous networks and others that I've not listed here to formalize networks for data provision and building an infrastructure for harmonized fair data. I will, for the rest of this talk, concentrate on the Alpha network as an example of a collaboration among multiple sites bringing together infectious diseases data from community-based studies. And then the Inspire network is an example of how the data coming from these collaborations can be enhanced and be made shareable using infrastructure that's reusable on the basis of data standards, and openness and collaboration. So the Alpha network is a network of 10 sites in Eastern and Southern Africa, collecting bringing together HIV data and analyzing those data to give insights or epidemiological insights based on the secondary analysis of these data coming from health and demographic surveillance systems. The 10-member network, the HDSSs in Eastern and Southern Africa, as I mentioned, and the Secretariat for the Alpha Network to date has been based at the London School of Hygiene and Tropical Medicine. Just to give an example of the data coming from the Alpha Network, the templates are circulated among the members of the network to collect household residence data, providing the denominators for estimation of rates, HIV testing dates and results, deaths, and verbal autopsies to give ideas on the probable causes of death, HIV care and treatment data, among other data sets. Traditionally, some of the Alpha Network data have been mainly created using packages such as statistical packages such as data. Currently, with funding from the Wellcome Trust, the Alpha Network is building data transformations in the Pentao data integration software. So building on the experience of the networks that I just listed, the experience there was that there was evidence that data could be brought together and be analyzed, after having been harmonized. But the processes being used were not capturing much of the provenance of the data involved, and also the data transformations or the data specifications were very specific to the diseases or the type of analysis that were being performed on this data. So going forward, there are current efforts that I'll talk a little bit more about in the a few slides remaining, to enhance, bringing the networking of members from the health and demographic surveillance system, and hopefully even outside HDSS in the future, and leveraging use of data support collection networks, and also providing feedback to the producers of those data. So the vehicle through which we are working on enhancing the data collection and processing and sharing is a project called Inspire. We are currently in the first phase of Inspire, funded by the Digital Innovation for Development in Africa. We got a seed grant to explore partnerships and to build prototype infrastructure for fair data production, with the intention of sharing beyond just the producers of the data. So the Inspire network has two components, a governance and management component and a technical infrastructure component, bringing together data from health and demographic surveillance systems in ways that make them findable, accessible, interoperable, and reusable. And providing services that allow users of those data to discover them, access them, and analyze them in accurate ways. So there's the governance aspect of the Inspire network, and then there's also the technical aspect in which we are applying principles of openness, standardization, and through metadata standards and other data standards. One of the key things at the center of the Inspire data infrastructure is the implementation of a common data model that has been commonly applied in electronic health care system data in Europe, in the US, and to some extent in Asia and Africa. So we are taking this common data model, transforming the data that come from health and demographic surveillance systems, putting them in this format that's more widely used outside the network of the members of Inspire. Beyond that, we are developing ways of bringing in the data into the common data model together with the metadata, and then also on the other side, once the data have been harmonized in this more generic way, providing discoverability and also workbenches for further transformation of those data and analysis of those data. So this is very much work in progress. Our goal and our hope is that at the end of the first phase, we will have a demonstrable prototype of the platform, of this Inspire platform, showing how infectious data coming from communities such as the health and demographic surveillance systems can be made more valuable with a richer and standardized metadata, and also how they can be shared at the same time, giving credit to those who are producing those data. Thank you very much. My acknowledgements to the members of the Inspire network and networks that have led, that have we have interacted with in the past, and we are building on this. And also acknowledgements to the funders who have been funding HDSSs, and last but not least, the participants, the study participants contributing data to the health and demographics.
Thank you very much, Chifundo. Thank you very much. So thank you to Chifundo for your presentation, and we'll move straight on to the next presenter, who's Alejandra Gonzalez Beltran from the UK's Science and Technology Facilities Council. Alejandra, over to you.
Thank you, Simon, and hello everyone. It's great to be part of this session where I'm going to be talking about data bridges for scientific and official data integration. So first of all, I'll tell you a bit about myself, as I come from the science domain. I'm the software engineering group leader at the scientific computing department at STFC. Here you can see a view of our campus. And what we do is mainly software for data management of the data that comes from the large scale facilities that we have on campus. But I'm also very interested in data standards for sharing fair data and enabling research reproducibility. So a theme across all of the presentations today were about challenges of making data available and how discovering data and integrating data could help in addressing scientific and societal challenges. And the fact is that usually the data are siloed, and there are disciplinary, geographical, administrative boundaries. So we do need common efforts that are multidisciplinary, multi-stakeholder, and cross-jurisdictional, as this session promotes. There are other technical challenges. I'm going to discuss some of them, and challenges as well around having computational infrastructure to support this. So to motivate the example of bridging scientific and official data on sustainable development goals, I'm going to talk about an example from the Center for Environmental Data Analysis, which is jointly part of STFC and the Natural Environment Research Council in the UK, where they do maintain systems and a portal for Earth System Grid Federation, where the modelers for climate change can submit their data. They maintain system for replicating and archiving this data for the long-term preservation, which is also accessed by the Intergovernmental Panel on Climate Change authors. And they use this data to generate the IPCC report, which in turn is linked to the Sustainable Development Goals and has connections to that. So the challenge that I'm going to discuss today aim at a vision in which we could track all this provenance of the data so that we can find the data that justifies the different targets and indicators on the Sustainable Development Goals. So when integrating data to address those challenges, we face many issues, and I thought to mention a few in the context of the FAIR principles, as it gives some way of categorizing them. So when we are trying to find data, we do face challenges on how to select the data so that it's representative of the question we want to answer. So there are issues around data equity that are very important. In terms of accessibility, we need to consider issues around sensitive and private data. When we try to reuse data, we need to make sure about its completeness, and if there are conflicts when we are aggregating data from different places, and consider its provenance. And on the interoperability aspects, there are different layers of challenges, and that is what I'm going to focus on next. So when integrating data, there are different levels of integration that we need to consider. At the system level, where we exchange data across systems, we do need to consider common services and persistent identifiers and IRIs and that were mentioned in previous talks, and protocols and web services and APIs or application programming interfaces fall into this area of having the infrastructure that supports data discovery, access, and exchange. The next level that we can consider is the syntactic level. So the language or data formats being used for different types of data and metadata. Next, we have the structural layer that refers to the schemas that the different data and metadata need to conform to, where ideally there are automated validation processes. And at the top, we have the layer related to the meaning and the context of the data, and this relates to the semantics. And this is where we talk about vocabularies, and there were mentions of vocabularies in previous talks, like the HACCP vocabulary and the Sustainable Development Goal Interface Ontology that I'm going to also refer to as examples. So these vocabularies and mappings between vocabularies provide this meaning and context of the data that is so important. And in fact, it provides the main entry point for data bridges across different domains. Because as you can imagine, in a specific domains, in scientific domains, for example, there is usually agreement on formats and schemas, and even that could be difficult, but that's more difficult really across domains. So the semantic layer is really where we can think about these data bridges to help us integrate data. So I'm going to focus on how vocabularies and persistent identifiers that are also related to vocabularies can help in this semantic integration. So one example I want to mention as a potential data bridge for catalogs and data resources, as in all domains we deal with data resources and data catalogs, is the W3C data catalog vocabulary, or DCAT, in which I'm involved, which is a domain agnostic set of terms that allow to describe catalogs as well as data sets and data services and resources in general that can be catalogued. It has been extensively used for governmental data, and in the version 2 of the vocabulary, we focus on addressing use cases around research data. So I think it's a good candidate for interoperability for data catalogs and data resources. So we can imagine that the DCAT vocabulary could be used across data catalogs or data resources in different domains, including the SDGs, targets, indicators, data, climate change. So for example, the CEDA example would fall in this area, and bringing the mention to the hazards vocabulary and disaster risk reduction data would be another way of linking all of this together. And then if we think about the more domain-specific aspects of each of these data catalogs, we can consider the hazards vocabulary that was introduced by Virginia, that also links to other more scientific domain ontologies like the chemical entities of biological interest, like ORCEBI. And in turn, the SDGs interface ontology also links to CEBI and the environment ontology that it could be used and is used in climate change models and data. So here I want to bring the point that we could consider vocabularies at the domain agnostic level and domain specific levels, and look at the integration of them across domains. So going back to the motivating example, the vision is that if we had and we used the identifiers for data that these catalogs produced, and we included identifiers for the people involved, so the data producers as well as the IPCC report authors, and we linked to identifiers from the SDG ontology and all the work that Remo and Cecilia mentioned about machine readable documents, we could realize this vision of tracing the data underlying the different indicators and targets in the Sustainable Development Goals. So what I want to mention as part of this is that there is a lot of ongoing work around guidelines and technical aspects of data bridges, and in particular semantic data bridges. And CODATA and other organizations are involved in different working groups around semantic interoperability, as I am, together, for example, with the Research Data Alliance. So, and we're working on producing guidelines and supporting resources and tools that could help in this domain. Also creating vocabularies and mapping between the vocabularies. And there is also ongoing work, for example, at my organization in STFC that looks not only at integrating this heterogeneous data, but also at providing the computing infrastructure that supports building models across different data sets. And this is examples like Daphne, that is the Data and Analytics Facility for National Infrastructure, and the UK Climate Projections Project in collaboration with the Met Office and the Environment Agency. So to conclude, I just want to emphasize that data discovery and data integration are crucial for addressing the global challenges, especially we want to follow an evidence-based approach. Semantic interoperability is an enabler for integrating scientific data with official statistics data. And for building data bridges, we do need to focus on having persistent identifiers and vocabularies and ontologies that can be used to link the different data repositories. And watch this space as there is ongoing work around guidelines and technical aspects of how to create these data bridges. With that, I want to thank people that, that I've been discussing these topics with. And thank you very much. And we're ready for the next speaker. Thanks.
Thank you very much, Alejandra. Thank you. So thank you to those speakers. We'll now move on to our final speaker, Arifan Gregory, who will talk about the Data Documentation Initiative's cross-domain integration specification, and then we'll provide a wrap-up and summary of the session that you've been listening to and watching. Thank you, Arifan. Over to you.
Simon, hello, can you hear me?
Loud and clear.
Okay, very good. Yeah, my name is Arifan Gregory. I'm actually a consultant. I've been involved in some of the different work that you've seen today, notably the INSPIRE project. I've spent a lot of my career working with international standards, metadata standards around research and scientific data, DDI, SDMX, GSIM, if those acronyms mean anything to you. Simon's asked me really to address briefly DDI CDI, which is a little bit of an extension of what Alejandra just presented, but more on the structural bridging side, and then to do a little bit of a wrap up for the session themes. So, hello, there. So those are really the two topics I'm going to touch on today, and you can see my summary of themes, little preview there. But I'm going to move first to a discussion of the Data Documentation Initiative cross-domain integration, DDI CDI, that specification, which is sort of a new kind of metadata model. I think there's been a bit of an evolution in the understanding of the role that metadata can play when it comes to data. And you heard Alejandra mention the term provenance, and that's an important thing. And data integration is obviously a major topic these days. And DDI CDI is designed to work in that space. Give you a little bit of background first, which is that the DDI standards have traditionally been sort of very granular and machine actionable metadata standards, but still typical standards that describe data sets and collections of data sets. And there are two products there, DDI Codebook and DDI Lifecycle, that are basically used in the social, behavioral, and economic sciences, and also a lot in official statistics at the national level. So they're used a lot in the research world, but they don't deal a lot with hard science data. DDI CDI is a different kind of standard. and it's not designed to replace traditional metadata. It's really designed to complement it, to supplement that information with metadata that is more focused on data integration and describing provenance in a detailed way. What it does is simple. It allows you to describe a very wide range of data coming from different domains, and that means a lot of structural variation. Emphasis on the structure here. It allows you to describe processing as data goes from one form into another, and that is a key part of provenance. And the most important thing maybe is that it allows you to actually track how individual datums, individual data points are used across that entire chain. I'm going to show you a typical, what I consider a typical data transformation. And this is just an example, but data as it's used exists in different related forms connected by processes. And I think this is true of almost any use of data in research and statistics. And you start with some kind of raw data, and that could be a sensor, that could be data coming from a survey, but that raw data is rendered fit for analysis by some amount of processing. And that might be very minor, it might be more invasive, if you will, but it includes data cleaning, it includes combining values to produce other values. But at the end of the day, you end up with an analysis-ready data set, if you will. And we often call that microdata or unit record data, but there are different flavors of that. And the data in the raw data has a strong relationship to the analysis data, but it's not identical. And there's a process between them. Very often the analysis itself involves regressions and tabulations, and it may be computing events in the example that we saw from Chifundo, for example, as one example. But the point is you end up with a different data set that is heavily based on the analysis data set, but is not identical to it. And the measures are often computed from the observations in the microdata and so on. Again, two different forms of the data, but with a relationship described by a process. And then in the case of, for instance, the SDGs, we have indicators that are the ultimate result of this. And you might track those across time, but they're very highly qualified and highly processed views based on this entire chain. And DDI-CDI really describes this process by focusing on the data at each stage and indicating what role is played by each atomic bit of data in that form that the data is taking. And that changes as you go across the chain, but the datums, although they're modified, have relationships to each other and may be identical. And so it looks at the processing and it looks at the structure of the data at each step of this process. It's not always 4 steps, it could be more than that. But that's what DDI-CDI is focused on, is describing that chain. When you think about the demands of cross-domain data sharing, I think you see that it's very different than traditional sort of secondary use of data within domains. Within domains, there's a lot of informal knowledge that is actually used when you repurpose data. And people understand where the data comes from, who's producing the data, what the projects are that are producing what kind of data. There might be a domain literature, and they'll use that to locate data that they want. There are very often common tools and common data structures, and the people know each other. And so there's a lot of context around data within any given domain or sector. In a cross-domain case, that is much more difficult because all of that background goes out the window. There is no literature, single literature. You may not know the people who are producing the data. The tools might be unfamiliar. The semantics are different. All of those things are a major problem when it comes to integrating data from outside your domain with the data that's more familiar, that you need to do your research. I've seen estimates that say that as much as 80% of the effort in a research project goes into preparing and integrating data to make it fit for analysis, not even to get to the point of analysis, but just to get the data to work together in an integrated way. I'm not going to say 80% is a typical case, but it can be that much. It's an expensive manual process. And that's why DDI-CDI takes the focus that it does. It does a couple of things. It comes with a richer set of data provenance information. Now, data provenance can mean a lot of different things, but at the core are the questions, what were the input data And what did you do to them to produce the data I'm looking at, that I'm working with? Because a lot of really understanding the data results from that kind of provenance. And so we actually do an implementation of the prov ontology as part of DDI-CDI and provide a little bit of glue to connect existing standards with a description of the data so that the different forms of the data can be connected by pretty fine-grained descriptions of the process in various standards. The other thing that it does, and this is maybe more powerful, is that it allows you to take a description of the data that is your input data in one form, and because you understand the roles being played by the data points, you can predict what they must become in the form of data that you need to integrate for your analysis. And that sounds complicated, and it is complicated, but what it means is that you can begin to automate the integration of data at a structural level. And that is a huge time saver because you can do it programmatically. Now, this does not solve the semantic issues that Alejandro was talking about, but it can begin to automate the solution to structural integration. And that's a very powerful thing. The data becomes easier to use when it's coming from external domains because I can take your data feed or your event data and turn it into the rectangular table that I need or the data cube that I need. And there's processing in there, and I understand that, but there's also a structural transformation that needs to happen. And now I can begin to automate that. And that lowers the cost of integration. I have more information about how the data has come to be, what it is. And the other thing it does, and this is, I think, the most intriguing aspect, when you think about what Alejandro presented around semantic bridging and semantic mapping, you can see that if we have structural bridges and a structural framework to plug that mapping into, that you have two very important parts of the same thing, and both are needed for data integration. They're very complementary and probably far more powerful together than either one is alone. And I think there's a lot of promise here. I'm not going to talk any more about DDI-CDI right now. And if you're interested, we're currently in the public review stage. The standard will be released in the first quarter of next year. But if you go to that link, you'll see what's available for download. There's a lot of documentation and examples. We are currently conducting workshops and webinars in collaboration with CODATA. And if you're interested, contact us because we can invite you to some of these groups. We're doing things like looking at cross-domain use cases and looking at the data, applying the standard models and seeing how, if it all works the way we expect it to. And so any of those emails will get a hold of the right people. I'm going to switch gears now and step back a little bit because I think we've seen a number of presentations on a pretty wide range of topics. And I kind of want to give at least one impression of what the themes were and how they're connected, what the unifying story is here. May not be obvious. I was going to have one of those great tricolor flags that we know from events like the French Revolution, but that's very problematic in a UN setting because light blue on light blue on light blue doesn't work. And it's an international forum and the colors are nationally specific. So I just went with white here. And it's not white for surrender, it's white for hope, okay? Because my themes are openness, standardization, and collaboration. And I sort of want to pull out a few little topics from the presentations we saw to show why I think this sort of comes together to explain how they're connected and the vision that emerges. Virginia Murray talked to us about the hazard classification work, and I think it's quite an impressive piece of work, I have to say, Virginia. It's important, obviously, and it's a large-scale international standard. It's hard to think of a data set that is more cross-sectoral than the stuff they're working with in UNDRR. So it's an impressive piece of work. The thing that strikes me is that unlike a lot of statistical classifications in the past, this was not created by a team of UN experts who decided what they wanted and then told the world that they were going to report the data in that form. That's not what happened here. And I think we've all had experience of that kind of classification, and it causes problems for data quality, among other things. It's hard to turn your classifications into the ones that are being asked for sometimes. And because you're munging the data to make them fit into that framework, often the quality of the data degrades. And you don't admit that maybe, but it's pretty well known that that happens. So What we saw in this instance was a really good collaboration across sectors and domains, across user levels, and from a lot of different perspectives. I mean, I know people who were involved in this work that were technologists and not content experts at all, but that they brought a different perspective to the work. And so I was very impressed with the sheer number of names you showed us on those slides, Virginia, because they were a lot of people from different perspectives and different roles looking at this. And good standards incorporate the input from all types of users. Nobody likes a good standard, but everybody can live with it and it will get the job done. And I think what we see in the hazard classification work is that kind of collaboration. I think it's super important. The presentations from the UN I found very engaging, and they're a little further afield because they deal with a lot of information that isn't data as such. But I've worked in the 2000s with a lot of UN organizations around STMX. And in those days, it was the MDGs that we were focused on. But it was pretty clear that the UN system was interested primarily in enhancing and better managing and organizing data reporting within the UN system. And that was an admirable focus, and I think a lot of progress was made. And it's pretty clear that that work has continued on to the current day. But I noticed something new, because I haven't been involved as much with UN organizations since, which is that there's an attention being paid outside the UN system and a recognition that you need to do more than just publish the data and the documents as PDF on a website somewhere. That they need to be machine actionable and standards-based and open to connections from the outside of the system. And that is a huge deal. You know, I'm a data guy, and when I see things like the SDG interface ontology and the IRI, that's very important. And it's also important that you can connect this to things like the resolutions that are being passed. And so I think all of this is quite impressive and really important. And that's especially true in light of what we heard Chifundo Kansula present on, because it's pretty clear that there is some very high value data in an important area in the scientific community that isn't actually visible from the UN level. Now, it turns out, and I don't think Chifundo said this, but that the data that he was talking about in Alpha does make its way into the SDG indicators by a sort of non-direct path. And I think it's through UNAIDS, if I remember correctly, or WHO, but you would never know that that had happened. There's no way to navigate from the SDG indicator back to the data in Alpha in East Africa, Southern Africa. There's no way to do it, even though it might be very important for what your work is. And what we see in Inspire is a bunch of these organizations coming together to provide fair access to this data that's standards-based and open, and to provide visibility into it in a way that doesn't exist today. And you can see where I'm going with this, because the idea that you have the SDG indicators available as machine actionable targets in an open way, and you have the data at the bottom that contributes to them, you can understand we could easily connect those two things by bridging them in a structural level and a semantic level. And so I think we're beginning to see how this entire vision comes together. And the important thing to me about what Alejandra presented was the semantic bridges, basically. And we're seeing a pretty intense culture of ontology and standard vocabulary in the world. And we're seeing a lot of agreed domain models, and they're machine actionable and expressed in ways that are computable. That's happening in the scientific domains, absolutely, but also increasingly in official statistics. And if you combine that kind of an approach with the structural frameworks that you can build with standards like DDI, CDI, I think you can begin to have a picture of how things like the SDG indicators could be connected to their input data in a computable chain that would be navigable and comprehensible, and begin to automate the actual use of the data at different levels. And that's an incredibly powerful vision. That kind of an infrastructure is a little bit of a holy grail, I think, for a lot of us. Where are we now, though? We don't have that infrastructure today. We don't have seamless, efficient access to all the data in the world on demand. And we may never have that, honestly, but we can get a lot closer to it, and we can do things a lot more efficiently, and we can respond more effectively at a policy level, and we can produce better research if we have better access to all of the data. And I think we all agree on that. What we do have, though, and I think we see evidence of this today, is a lot of the critical elements that would go into that kind of infrastructure. We can begin to see what the solution is going to look like, right? And that, to me, is incredibly important. At the end of the day, though, I come back to collaboration and why I think that's so important. Because this problem is really way too big to be solved by any single organization or technology. When we heard about the volumes of documentation coming out of the UN in New York, that is staggering. It's a huge amount of information. You have to automate that approach, but we're talking about a problem that's several times larger than that, not just the documentation, but the data. And there is no magic bullet here. No single answer is going to be the answer. But we can come up with a solution by collaborating, by using the pieces we have in hand, and by combining those perspectives and tools and standards and ideas in good ways. And I'd like to point back as an example to something Simon mentioned in the introduction, which is CODATA's Decadal Programme. Because what we have there is the idea that people from across different communities can come together and work together, focused on sort of real use cases and grand challenges, and identify how to solve the data problems and the various problems they face by working together with the existing toolkit, and to produce not some sort of standards or new tools, but guidelines for how you can solve those problems in a coordinated way with the available tools and standards. And if people voluntarily adhere to those guidelines, then the kind of infrastructure we're talking about can come into being. Now, you think that's crazy maybe, but I'm going to point something out. We use the World Wide Web every day, and effectively, the web was created in exactly this way. The W3C doesn't produce standards, it produces recommendations. And nobody ever went around validating that everyone's HTML was correct, because honestly, it was not. And yet, because it was valuable to have, people participated voluntarily in the web and made it happen. And I'm not going to say this will be another World Wide Web, but I will say that that dynamic, that ability to create big infrastructure with voluntary adherence to guidance, to informed guidance, is an effective thing in the technology world at this level. And so I really think that there's a way forward here. And it's going to depend on that collaboration and on some of the tools we've seen. So I'm going to leave you with a picture. And Remo showed you the road ahead, and he gave you a pretty classic example of the road ahead. I have a different road ahead picture. We haven't reached the Emerald City yet, but we can see how we're going to get there. And you can understand that there are actually 5 individuals when you count Toto in the basket there. And they're all arm in arm, and they're pointed in the same direction, and they know where they have to go. Now, you can't see the entire road ahead because there are some dips and things. And if you've seen the movie, you know that there are actually some flying monkeys in one of the dips. So there will be challenges. But I think it's pretty clear what we have to do. I think we can produce something truly amazing in the foreseeable future if we work together and go forward. And we're beginning to see the pieces of what that solution will be. So I found this session incredibly hopeful in that way. So we aren't actually there yet, but we know how to get there, and we can see a clear way forward. And with that, Simon, I think that's pretty much the summary that I have.
Thank you very much, Arafan. I'd like to thank all our speakers, Virginia, Remo, Cecilia, Chifundo, Alejandra, and Arafan, also for that summary. Thank you very much.